Hi, this is the 5th video for week 3 trigonometric functions. This is the 5th of 7 videos for week 3 and covers solving Pythagorean identities. These videos are intended to help you with the online content for week 3. We recommend that you watch this video with your pen and paper and pause at the relevant times to work through the examples for yourself. Solving Pythagorean identities. If we were to solve 2x minus 1 is equal to 0, this one we're quite used to by now, so we add 1 on both sides, we get 2x is equal to 1. Divide by 2, x is equal to a half. When we work with our Pythagorean identities, we actually proceed in the same manner. So if we had here 2 sine theta minus 1 is equal to 0, we're going to add 1 to both sides. So we get 2 sine theta is equal to 1. We divide both sides by 2, and we end up with sine theta is equal to a half. However, this is not our final answer. If we look at our sine curve over here, and here's our sine curve, we've put a line in here where y is equal to a half. We can see we've got two solutions here for sine theta equal to a half. If we split this curve into our different quadrants here, we can see here in quadrant 1 and quadrant 2, we have an answer for here where our sine theta is equal to a half. If it was a negative a half, it would be appropriate to use quadrants 3 and 4. So we have two solutions for sine theta is equal to a half. And what we have to do is think about our standard triangles. So we've got here our two triangles. We've got 1 root 2 pi on 4. Here we've got 2, 1, here square root of 3. We've got pi on 3 and pi on 6. And here we want sine of something to be equal to a half. So here, if we look at pi on 3, it's root 3 on 2. Pi on 6, it's 1 on 2. So sine of pi on 6 is equal to a half. So that's going to be our first answer here in our quadrant 1. Here we're going to have pi on 6. And we see we've got answers here in quadrant 1 and quadrant 2. We can also use our all stations to central rule, where sine is positive in quadrant 1 and quadrant 2, negative in 3 and 4, so we don't have a solution for those two. In quadrant 2, we have here, we've got 0, pi on 2, pi, 3 pi on 2, and 2 pi. Here we have pi minus pi on 6 for our second result. So our two solutions are going to be pi on 6 in quadrant 1, and then in quadrant 2, we're going to have pi minus pi on 6. So to work this one out, we can make this 6 pi on 6 minus pi on 6. We end up with 5 pi on 6. So here are our two results for here, 2 sine theta minus 1 is equal to 0. Okay, moving on to our examples here. We want to solve the following problems. So first of all, we've got 4 sine squared theta minus 1 is equal to 0. We're going to add 1 to both sides. So we get 4 sine of theta is equal to 1. We're going to divide through by 4. Here, sine squared theta is equal to 1 on 4. Now we want to take the square root of both sides. So square root of sine squared theta gives us sine of theta. And we can split here our square root into 2. We've got square root of 1 on square root of 4. So we end up with 1 on 2. Here, and we notice here, we can make this positive or negative, because our square root, negative 1 squared, or negative a half squared, will still give us a quarter. So what we have to do, we think about, okay, it can be positive or negative. So if we think about our sine curve, here's our sine curve here. We've got positive a half and negative a half. So here, this sine theta can be any of those values there. So we're going to have 1, 2, 3, 4 different solutions for this problem. And if we look at our quadrants here, we have a solution in each quadrant. We think about our all stations to central. We know we're either positive or negative in each of those quadrants. So that's what we're working with there. So if we put in our space up here, we're going to draw our unit. It's here. We've got 1, 2, root 3, pi on 3, and pi on 6. We've got 1, root 2, and pi on 4. So here we know, well, sine here of pi on 6 is equal to a half. So if we think about this on our actual circle here, we've got pi on 6 for quadrant 1. We're going to have all of these values here. We'll have pi on 6 in here, pi on 6, pi on 6. So for quadrant 1, our result will be pi on 6. For quadrant 2, it's going to be pi minus pi on 6. Quadrant 3, we're going to have pi plus pi on 6. And quadrant 4, we're going to have 2 pi minus pi on 6. So we can make these values we can work with here. So we've got 6 on 6, 6 on 6, and here this becomes 12 on 6. So our values end up being pi on 6, 5 pi on 6, 7 pi on 6, and 11 pi on 6. Okay, looking at our second problem here. We've got 2 sine squared theta minus cosine of theta is equal to 1. And similar to working with x's and y's in the same equation, we want to change them so we can work with just x's or just y's. So here we remember, well, sine squared theta plus cosine squared theta is equal to 1. So if we change this sine squared theta into here 1 minus cosine of sine squared theta. So we have 2, 1 minus cosine squared theta minus cosine of theta is equal to 1. So we have 2 minus 2 cosine squared theta minus cosine of theta is equal to 1. We rearrange to the other side. We're going to get 2 cosine squared theta plus cosine of theta minus 1 is equal to 0. So now we have an equation we can work with. To get 2 cosine squared theta, we're going to be multiplying 2 cosine squared theta by cosine, 2 cosine of theta multiplied by cosine of theta. We see we have a negative at the end and a positive in the middle. So we know we're going to have one negative and one positive. We want to have here, to get this positive cosine of theta, we want 2 cosine of theta to be multiplied by positive 1. And then cosine of theta multiplied by negative 1. So we end up with cosine of theta in the end there. So now we have 2 possible solutions. If we look at 2 cosine theta minus 1, this part here could be equal to 0. So if we here 2 cosine of theta minus 1 is equal to 0. So we add 1 and add 1. So here we're going to get 2 cosine of theta is equal to 1. Divide by 2, divide by 2. We're going to have cosine of theta is equal to a half. If we look up here, a half is here. Cosine of pi on 3 is equal to a half. So we have here cosine of pi on 3. If we think through our cosine curve, we'll put that up here as well. Our cosine curve goes like this in our different quadrants. And here we're wanting equal to a half. So here's a half. There's 1. We're going to have values here. 1, 2, 3, 4. So in our quadrants, 1 and 4. If we do our all stations to central, so we look here in quadrant 1, cosine is positive, and in quadrant 4, cosine is positive. We put our pi on 3 in here, so our first value will be pi on 3. And our second value here will be 2 pi minus pi on 3. So working this one through to work with, we're going to 6 pi on 3 minus pi on 3 will be 5 pi on 3. So there are 2 values that work for this 2 cosine of theta minus 1. If we have cosine of theta plus 1 is equal to 0, we take this out and we add 1 to both sides. So subtract 1 from both sides. Cosine of theta is equal to minus 1. If we look on our curve here, there's our minus 1. So if we look here, well, cosine here, this is pi on 2, pi, 3 pi on 2, and 2 pi. So we see here where cosine is equal to pi, we get this negative 1 here. So this value here, we're going to end up with pi. So our 3 solutions for this problem will be pi on 3, pi, and 5 pi on 3. Okay, so moving on to our third problem here. we have 2 cosine squared theta plus 3 sine theta is equal to 3. So same as before, we want to change this cosine squared theta into a sine squared theta. So we have our 2. So well, cosine squared theta is 1 minus sine squared theta plus 3 sine of theta is equal to 3. So we get 2 minus 2 sine squared theta plus 3 sine theta is equal to 3. We move them over to the other side. We're going to get 2 sine squared theta minus 3 sine theta is plus 1 is equal to 0. So now we work through this. We get here to get our 2 sine squared theta. We're going to have 2 sine theta multiplied by sine of theta. We notice we've got a negative here and a positive here. So both of these must be positive. Positive times a positive. So negative. So we notice both of these here must be negative. So we look here, we have a negative and a positive at the end. We are, well, negative times a negative is equal to a positive, so these must both be negatives. And here we're going to get minus sine theta, and minus 2 more sine thetas is minus 3 sine theta there. So we have, again, 2 different solutions. So here if we look at 2 sine theta minus 1 is equal to 0. We get 2 sine theta is equal to 1. Divide by 2, sine of theta is equal to a half. We know sine of pi on 6 is a half. And here are all stations to central, or looking here, we know we're in quadrants 1 and 2. So we've got pi on 6, pi on 6. So our 2 values here will be pi on 6 and our pi minus pi on 6, which is 5 pi on 6. So then looking at our second part here, we have sine of theta minus 1 is equal to 0. So we get sine of theta is equal to 1. If we look here at our sine curve again, we see our value 1. In this range for 0 to 2 pi, we only reach that 1 once, and that's here at pi on 2. So for this one, we're getting pi on 2. So we get 3 results for this equation here. We have pi on 6, pi on 2, and 5 pi on 6.